Hi guys, welcome to lesson 3 in unit 5. We've been talking about functions in lesson 1 and 2, and now we're going to talk about graphing functions. So we did a little bit of a review on graphing earlier, but let's talk about graphing in terms of using function notation and this idea of inputs and outputs. So your aim today is that I can make a table from a function and use the x and y values to graph the function. I can also determine maximums and minimums from the graph. Graphs are one of the most powerful ways of visualizing a function's rule because you can quickly read outputs given inputs, meaning you can see points on the graph very clearly. You can also easily see features such as maximum and minimum output values. Let's review some of those skills in exercise 1. Exercise 1 says, given the function y equals f of x, defined by the graph below, answer the following questions. So this is called a parabola, this curve on this graph right here on the grid, and it's our function. So we can, this is f of x right here, this curve. So A says find the value of each of the following, f of 4 and f of negative 1. So remember, f of 4, that's like saying where the function has an x value of 4. So I'm going to go over to 4, 1, 2, 3, 4, 1, 2, 3, 4, and go up until I find the point, and there's my function at 4, which gives me an output value of 1. So I went over 4, 1, 2, 3, 4, and I looked up to 1 to find f of 4. Okay? Now I'm going to try and find f of negative 1. So I'm going to go to the graph, remembering that negative 1 is my x value, so I'm going to go to the left one, and I'm going to go all the way up to 1, 2, 3, 4, 5, 6. So f of negative 1 is 6 at the point negative 1, 6. Remember that what's inside the parentheses is x, and what you find is your output, which is y. We've done this for the last couple lessons now. Okay? B, for what values of x does f of x equal negative 2? This question is now saying, hey, we're looking for our input given that the output is negative 2. So this is saying, where is y negative 2? So I'm going to look on my y-axis, which is the one that goes up and down, and y is negative 2 is right here. So I'm going to draw a line through negative 2, and these are the two places where it crosses the graph at y equals negative 2. So let's label those points. This is the point 1, negative 2, and this is the point 1, 2, 3, negative 2. So I actually have two answers for this. X equals 1 is an answer, and x equals 3 is an answer, because x at 1 right here and at 3, it both hits the graph at these 2 points at y equals negative 2. So that's okay. Sometimes in functions you're going to get two y values that are the same but different x values. That's okay. Letter C says state the minimum and maximum. So when you think of the word minimum, you're going to think of the word like the smallest, right? It's the minimum amount, so it's the smallest amount. So if I look on my graph here, where is this graph the lowest? Right there at that point. That is my very lowest point that this graph reaches. So what is that point? If I go over 1, 2, and 1, 2, 3. So it's over 2, down 3. So my minimum is 2, negative 3. Oh, my pen. I'm telling you, I need to get myself a new pen because this one is always messing up. Alright, so minimum is at 2, negative 3. You could also just say a minimum at negative 3, but I always like to give the x value as well. Now the maximum value of this function is a little bit tricky for a couple reasons. It's tricky because there are actually two places on this graph that's the highest. Maximum means what is the highest, right? If I say I have the maximum amount, I have the highest. Well, these two yellow dots I'm drawing are really the maximum 2 points on this graph. Now the only reason we have a maximum here is because there's no arrows at the top. If this had two arrows, like, let me draw them. If this had two arrows like this, where this graph was going up forever and ever, Your maximum would be infinity, right? Because it would go, there's no stopping point, it would go on forever. But in this example, they didn't give us arrows, so we have to assume that this graph actually stops here and it stops here. So really this graph has two maximums. So if I'm going to label these coordinates, I'm going to go 1, 2, 3, 4. So I go over 4. Oh, sorry, 5. Miscounted. So I'm going to go over 5. And how many do I go up? 1, 2, 3, 4, 5, 6. So I have a maximum at 5, 6. And I have another maximum at, here's the other one, -1, 6. So technically my maximum is still just one number. It's at just 6. Because when we think minimum maximum, we're going to think of our y values here. Okay? Oh my goodness. If my pen does this one more time. Okay. So the max and min are really y values. Okay? Again, if you ever have questions or want clarification, that's what class time is for, or you can email. Okay? Let's take a look at another example of graphing, exercise 2. So if we can read a graph to produce outputs, meaning y values, if we're giving inputs x values, then we should be able to reverse the process and produce a graph of a function from its algebraically expressed rule. This is a very fancy way of saying from the equation. Now this is something you guys did in middle school where you take an equation, you'd make a t-table, and you'd plot the points. That's basically what we're doing here. So we're just getting used to the notation and the language. So it says, consider the function given by the rule g of x equals 2x plus 3. So I have my function, 2x plus 3, and the first the first input, remember x is input, and your y, and this would be your output, that y, is -3. So we're going to take my function, 2x plus 3, and instead of having an x, what are we going to plug in? A -3. So I'm going to go ahead and go through here and do this to show that I'm just changing what I'm putting in for x each time. So let's use a different color. So for this one I'd put in -3. For the next one I'd put in -2. So do you see how I'm putting in a different input each time? And then I'm going to calculate each one of these and get a different output. So let's do the math. You can always use a calculator for this if you want to. 2 times -3 is -6. -6 plus 3 is -3. So my coordinate for this is my x value, which is -3, and then I happen to also get -3 for my y value. If you like, try filling out the rest of this t-table on your own. So you can pause the video and try and see if you've gotten the hang of it. -2 times 2 is -4. -4 plus 3 is -1, so my coordinate becomes -2, which was my input, and -1, which is my output. The next one is -1 times 2, which is -2. -2 plus 3 is a +1, so -1, 1. Fourth one, 2 times 0 is 0. 0 plus 3 is a 3, so I get a coordinate of 0, 3. Almost done. 2 times 1 is 2. 2 plus 3 would give me 5, so I have 1, 5. 2 times 2 is 4. 4 plus 3 is 7. So I have 2, 7. And finally, 2 times 3 is 6, and 6 plus 3 is 9. So if you are confused about where I'm getting these coordinates on the right, I am taking this x, the input I have here, and making that my x value here. So -2, -2, -1, -1. Then I'm taking my output that I get here, these outputs, and I'm pairing them up as the y value. Okay. Now that I have a list of coordinates, now all I have to do is plot each one. So I'm going to plot them with green. My first one, -3, -3, so I go to the left 3, and then I go down 3. So that's my first point. The next point, -2, -1, there's my second point. Check. Third point, -1, +1. Check. 0, 3. So they start at 0 and then go up to 3. 1, 5. 1, 2, 3, 4, 5. 2, 7. 1, 2, 3, 4, 5, 6, 7. And 3, 9 is right up here. This forms a straight line. And I knew that going in because if your function has just an x with no squared, it's linear, which means that you're forming a line. So this is called a linear function. It forms a line. We have a whole unit on just linear functions coming up, so they're really, really important. Linear functions form a line. Okay? So that's taking an equation, making a t-table, finding points, and then plotting them on a graph. Exercise 3. Never forget that all we need to do to translate between an equation and a graph is to plot input-output pairs according to whatever rule we're given. So no matter what equation they give you, it could have square roots, it could have exponents, it could have lots of different, pluses and minuses. All you have to do is plug in inputs and do PEMDAS, like from Unit 1, or use your calculator and find your output. So we're going to look at an example that's nonlinear, that's going to have a curve in it. And we call this kind of a function a quadratic function because it's got the squared. So when it has the squared term, we call this quadratic. We have a whole unit on those as well. So let's do the same thing I did for that first one. And I did this. I replaced the x with parentheses, and I'm going to just plug in whatever I have here. This one's actually pretty easy because it's just x squared. This is a very common graph, x squared. It occurs a lot in math. So again, I'm going to take my inputs and plug them in. So there's -3, -2, -1, 0, 1, 2, and 3. You're not always going to get the points given to you. Like for example, you see this table gives you the x values. Sometimes on the regions, they're going to expect you to just put in, and I would always start with a negative number. -3 is always a great number to start with if they don't give you the x values to fill in. Okay, so let's do the math here. -3 squared is this. Oops, I had it on eraser. Sorry. How did I get that stuck on eraser? If any of you guys want to get me a Christmas present, please get me a new pen for my tablet so I don't have to keep making these little mistakes every time. That would be awesome. Alright, let's try this again. Okay, -3 times -3 is going to give me a +9. So my coordinate becomes -3, +9. Remember, a negative times a negative is a positive. -2 times -2 will give me a 4. So I've got -2, 4. Again, pause the video if you want and try and come up with these pairs on your own. Even also after that, why don't you try taking these pairs and plotting them yourself on the grid to the right? Please, try it. See if you can do it. I'm going to keep working here. -1 times -1 gives me a +1. So I have -1, 1. 0 times 0 is just 0, so that's a very easy point, 0, 0. 1 squared is 1 times 1, which just gives me 1. So 1, 1. 2 squared is 2 times 2, which gives me 4, so I have 2, 4. And 3 times 3 gives me 9, so I have 3, 9. Now what am I going to do? The same thing I did for the last one is I'm going to plot all these points. So the first one is -3, 9, so I'm going to go to the left 3, 1, 2, 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's right here. That's this coordinate. Now I'm going to plot -2, 4, so 1, 2, 1, 2, 3, 4. That one. -1, 1, go over 1, up 1. There. 0, 0 is easy. That's the point right in the middle of the grid. 1, 1, so I'm going to go to the right 1 and go up 1. 2, 4, go to the right 2 and then up 4. And then 3, 9, over 3 and up 9. You're going to notice something very cool about a quadratic is that you've got some symmetry. See how these two bottom points are the same distance apart? Same with these 3 points. Quadratics always have that interesting pairing. So to connect these, be careful. You want to make it a curve so it looks kind of like that. And this little point should touch the bottom. Okay? So this should look like a curve. All the points are connected. and I've got a parabola. We also call this shape a parabola. It's a quadratic function. It always has an x squared in it for a parabola. Normally, I would put little arrows on the end here to say that this goes on forever and ever, but the table started at -3 and ended at 3, so I'm actually going to leave these arrows off because it didn't tell me to make it go on forever and ever. So stop that at the point 9. Okay? Alright, one more graph to look at, and this is going to be something called a piecewise graph, which we talked about a little bit in the last lesson, in lesson 2, but these look kind of funny because they look like chunks. So sometimes a functions rule gets all sorts of funny and can include being piecewise defined. These functions have different rules for different values of x. These separate rules combine to make a larger and more complicated rule. Let's get a feel for one now. So exercise 4, consider the function given by the formula f of x equals 2x plus 6 for x less than 0 and 6 minus x for x greater than 0. Your teacher is going to help you understand. So that's me. I'm going to help you out. This function is saying, look, we've got two different rules depending on the value of x. So let's take a look at this first part. So here's my first one, 2x plus 6 when x is less than 0. So if I'm saying that anytime x is less than 0, I'm going to use that rule, 2x minus 6. So let's look at my table. Is -3 less than 0? Yeah, so I'm going to use the purple one. The first one, the 2x plus 6. Is -2 less than 0? Yep, so I'm also going to use 2x plus 6. Is -1 less than 0? Yep, so I'm going to use 2x plus 6. Is 0 less than 0? No. So only these first three are going to use 2x plus 6. Now, look at the second part of the function. The second part says, okay, it's 6 minus x whenever x is bigger than 0, or equal to 0. So 0, 1, 2, and 3, those four inputs are going to use 6 minus x. So I use two different equations based on what my rule says. So sometimes it might not be 0, it might be something else, but in this function it says that if x is less than 0, use the purple equation. If x is greater than or equal to 0, use the red one. And I use colors to help you see the difference here, which you're free to do on your own if you need to use colors. Okay? So let's start with A and evaluate what this might mean. So for A, f of 4, you have to ask yourself, is 4 bigger than 0 or less than 0? So I know that 4 is bigger than 0, so I'm going to write a little note to myself here, down here, and I'm going to say, look, 4 is greater than 0, so I need to use this bottom one. So I'm going to say, okay, that means that I'm going to use 6 minus x. So I'm going to say, let's plug in 4. So it's going to be 6 minus 4, which equals 2. So f of 4 is going to give me an answer of 2. Now, on the other hand, f of -3 is actually less than 0. Oh, sorry, I meant to use purple. -3 is less than 0, so that means I have to use the other one. I've got to use this first one here, the 2x plus 6 equation. So I know that I have to use 2x plus 6, and I'm going to plug in -3 for x. 2 times -3 is -6, and -6 plus 6 gives me 0. Okay? So two different equations depending on the value of my input. Now let's fill out the rest of the table. I'm going to do myself a favor here, and just like I did the other ones, I'm going to write out the equation. So 2 blank plus 6, because I'm replacing the x. I know that all three of these use that equation, the 2x plus 6, but I know the x is going to be gone, so I'm putting parentheses like I did before. And then for the red one, I have 6 minus x, so I know it's going to be 6 minus whatever's in parentheses here. Okay? Now we just have to plug in all these values. So -3, -2, -1, 0, 1, 2, and 3. Now I can start finding my points. That's the tough part, is determining what input goes into what equation. So if Unit 4 was something that you didn't get to, I highly recommend maybe going back and taking a look at Unit 4, because Unit 4 talked about this notation, less than or greater than, and it's something that you should really review. Again, you can always email me or ask me for help if this is something you're struggling with, okay? Alright, let's calculate these. 2 times -3 is -6. -6 plus 6 is 0. So I'm going to put my 2 points together. I have a point at -3, 0. The second one, -2 times -2 is a -4. -4 plus 6 gives me a +2, so I have a point at -2, 2. 2 times -1 is -2. -2 plus 6 is 4, so I have a point at -1, 4. And now I go to my different equation, 6 minus 0. I can just drop the parentheses and write 6 minus 0 to give me 6, so I have a point at 0, 6. Same thing here, this becomes 6 minus 1, which gives me a 5, so I have a point at 1, 5. This becomes 6 minus 2, which gives me 4, so I have a point at 2, 4. And here, this is 6 minus 3, which gives me a point at 3, 3. So I've created my points, and now I have to do letter C, which says now graph it by plotting them. So I'm going to use my green color, like I've been using for graphing, and I'm going to start at the first point, which says -3, 0. So I'm going to go to the left 3, and up or down 0. That's this point right here. The next point is -2, 2, so I go over 2 and up 2. -4, -1, 4, I go over 1 and up 4. The next point is 0, 6, so 1, 2, 3, 4, 5, 6. The next point is 1, 5, so I go over 1 and then up 5. The next one is 2, 4, so I go over 2, up, oops, I miscounted. Over 2, up 4. Again, if my pen will cooperate. And then finally, over 3, up 3. Now how do I connect this? Because this looks super weird. I've got like this pattern going up and this pattern going down. Well, I'm going to go back to my rules. For x less than 0, if x is less than 0, that is this half of the grid. That's x is less than 0. So I know that when I go up like this, that it connects those three because it's all less than 0. Now the x is greater than 0 is this side, and I'm going to connect all of these. Normally, I would put arrows at the end like that, but in this exact example, they just give me a given table, so I'm going to stop at these 2 points. But normally, for a function, it would continue to go on forever and ever and ever. Okay? It's called a piecewise function. It's got 2 different equations for the function. Okay? This is the toughest part of this lesson, is this piecewise idea, but the concept is still the same, where you're plugging in an input, getting an output, and coming up with these points to plot on your graph. Okay? Reach out to me if you need help. Good luck on the fluency. I'll see you in class.